Okay, so let's talk circles. We're going to talk about all types of circles, and for today's lecture, we're going to cover everything from special segments within a circle, circumference, arc length, and radians. So let's go ahead and get started. First thing that we want to talk about are the special segments inside of a circle. Many of these you may be familiar with and some may be new. So for this particular circle, this is the circle C, and we identify the circle C based on its center. And the symbol used to identify a circle is, of course, right here as a sample is circle C. So the radius, or radii for plural, is from C to E, C to D, and C to F. So we have those three radii. Our next one is a chord. Now a chord is a segment whose endpoints are on the circle. We have two chords, and the key is that they have to be on the circle. So for instance, this segment AB, the points A and B are on the circle, as is with D and E. So the segments AB and the segment DE are each on the circle, and they are chords. Now what is special about the segment DE is that DE is also a diameter, because a diameter is a chord that passes through the center, and that is very, very important. We have to recognize that that center, C, is on that segment DE. All right, so let's go ahead and let's look at a sample and identify a few of these. Here's our new circle. First of all, let's recognize that our center is Q, so therefore our circle is Q, circle Q. All right, we have a couple of radii. So we have a radius from Q to Y. We have Q to Z, Q to X, and Q to W. These are all segments from the center Q out to the outer edge of our circle. We also have two diameters in this particular situation. So our diameters are the ones that go on the circle. They're chords that are on the circle but pass through the center. So here's W through the Q to Y. So WY is a diameter, as is the segment XZ. All right. Now it wants us to identify a chord. What we need to remember is that the diameters are also chords. So therefore, we need to list those because they do fall into the category of being a chord unless they tell us that we're looking for a chord that's not a diameter. So WY and XZ are both chords, and our last chord is the one that does not pass through the center, and that is WZ. All right, so there's a few of those types of identifiers. All right, so now let's talk about the diameter and the radius and their relationship. You may be familiar with this because, of course, again, it's something that we've looked at probably many years, finding circumference and area. So let's just clarify it. So the radius is half of the distance of the diameter. So we can say radius is diameter divided by 2, or we can look at the diameter is 2 times the radius. So in this particular example, if RT is 21 centimeters, then VS would be half of that, because RT is a diameter, where VS is a radius. So if our diameter is 21, then our radius is going to be half of that 21. Centimeters. All right, not too bad. All right, so let's talk about some circle pairs. We won't have a lot of these, but they're going to pop up periodically and in different types of problems. So our first set here is that we have two circles that are congruent. And the reason we know that they're congruent is because they have congruent radii. That means that they are the same size. Another thing to kind of keep in mind is that all circles are similar. So that means that they are proportional. And our last one we're looking at here is concentric circles. Concentric circles, think about a bullseye, rings on the water when you drop a stone. The center is going to always be the same for all of these circles, but their radiuses are different. Their radii are different as it goes out. So for instance, for circle A, we have a radius that's formed by AB, and then we also, in the circle A, we have a radius of AC. Two different circles, but yet they have the same center. So those are known as concentric